వెంకటేశ్వరరావు కాలేజ్ ఆఫ్ ఇంజనీరింగ్ అండ్ టెక్నాలజీ 2008లో స్థాపించిన కళాశాలలో MBA, NAC A గ్రేడ్ మరియు ISO సర్టిఫికేషన్ సాధించిన మొట్టమొదటి కళాశాల శ్రీ ముత్తవరపు వెంకటేశ్వరరావు కాలేజ్ ఆఫ్ ఇంజనీరింగ్ అండ్ టెక్నాలజీ త్వరలో అటానమస్ కాబోతోంది.
2014లో ISO గుర్తింపు, 2015లో రాష్ట్ర ప్రభుత్వంచే A గ్రేడ్, 2016లో NAC A గ్రేడ్, ఇప్పుడు NBA సాధించిన సంస్థ శ్రీ ముత్తవరపు వెంకటేశ్వరరావు కాలేజ్ ఆఫ్ ఇంజనీరింగ్ అండ్ టెక్నాలజీ.
Today's lecture, I will first discuss what is the concept of a process. Then I will discuss the if-else statement, which you will see is similar to the when-else statement. Then we will see the case-select statement, which is similar to the with-select statement that we saw in the previous lecture and lab. So, as a part of the sequential statements, first I will talk about how a process works. Then we will go deep into the if and the case statements. Then I will briefly look at the types of processes, that is a combinational process and a sequential process. And then we'll see a few modeling examples, just basic. We will also see this as part of future lectures as well, since this is a hardware design course. So we will look at some hardware modeling examples as well. So here are a few basic characteristics of what a process is. If you write a statement in a process, they are executed one after the other. The statements can appear only in a process or a subprogram. So let's look at the first two rules. If I write a process, let's say process begin, then whatever statements I write inside a process, and then I write end process, all these statements will execute sequentially one after the other. The process as a whole will execute concurrently. For example, if this is process A and then I have a process B, then process A and process B will execute concurrently, that is in parallel, but the statements inside the process will execute sequentially, one after the other. That said, we will look at variables as part of a future lecture, but let me just make it very clear that only sequential statements, so what you write inside a process, can use variables. So in short, you can use only variables inside a process. The other way around, variables can only be used inside a process. Okay? A process is a primary VHDL statement. It is concurrent. Remember, I said that all processes behave concurrently. Its primary job is to describe sequential behavior. And I mean by sequential behavior, when you have sequential logic like flip-flops, registers, latches. So the primary objective is to specify sequential behavior. These 2 points I just explained, that statements in a process are executed sequentially, and all processes in an architecture behave concurrently. Again, if there is process A, process B, process C, each of them have their own statements, but each of them, process A, B, and C, will execute concurrently. And very important point that I would like you to note, that sequential statements do not always generate sequential hardware. So I can use sequential statements to make combinational hardware. But again, the primary objective is to make sequential logic. So I hope these basic points were clear. A few more characteristics of a process. Now this is how you would write a process. You are familiar with these statements: architecture sequential of multiple is. This is where you would define your signals. We've looked at the signal definition last lecture. You would start with the keyword process. The signals that you write inside these two brackets, this is called as a sensitivity list. What it means is, what are the changes of the signals that my process is sensitive to? That is exactly what the question you need to ask yourself. That when my A would change, or B would change, or C would change, or D would change, then my Z would change. So effectively, my process is sensitive to changes in A, B, C, and D. If you have one signal, then your process will place only one driver on that signal. For example, here I have two statements. Z is A and B. Z is assigned C and D. So effectively, Z can have two drivers, but as the rule says, you can place only one driver. So how do you decide which driver to place? So you would take the last value assigned to it. That would be this one. Okay? Another very important point is, until the process gets over or the process is suspended, so you go from top to down, and when this is suspended, that is when the value will get updated. This point actually is very important from a simulation perspective. You can try this design in simulation and you will see that when you write this, there are two possibilities. If you synthesize this design, or you apply the synthesis tool in your software, it might give you an error called as multi-source. Multi-source as in there are two sources on the signal Z. However, if you just decide to simulate this design, then if you see that Z is updated with the last value of C and D, but it only gets assigned after this process is suspended. So, as I said, that you can either have a sensitivity list, but another way of doing it is with a wait statement. So I will explain this in the next slide, that you can either have a sensitivity list or a wait statement. It's either this or this, cannot be both. You can have only signal names which you can read. Please understand that in your sensitivity list you can place only signal names which you can read. So for example, say in your entity you have a port of type output. So let's say A is of the type out. Standard logic. I'm sure you are familiar with this by now. I cannot put A as part of my sensitivity list because I cannot read an output. So I cannot have A here. So you can have only static signal names for which reading is permitted, and that you can put in your sensitivity list. So this is what your sensitivity list will look like, and then you'll have the begin statement. And the execution of a process consists of repetitive execution. So what I mean by repetitive execution is you have a process with its sensitivity list, then you would have begin, and then you have these statements. So once the process is executed, if the sensitivity list triggers the process, then again the process will execute. So it's a very repetitive process. So again, let's understand these rules again, just to summarize. The process will put only one driver on the signal. Basically, if you have one signal, at the end of the day, there will be only one driver. The value of the signal is updated with the last value, as you see here, it's the last value. And the value will not be updated until you make one full run at the process, until the whole process is executed once. And then you can either have a sensitivity list or a wait statement. Only signal names that you can read can be put on the sensitivity list. For example, something with out cannot be put. And your process basically works on repetitive execution of all the sequential statements inside it. So the first point I've already mentioned, that your simulator runs a process when any one of the signals in the sensitivity list changes. So if your A changes, then your program is called, your process is called. So if A changes, then your process will be triggered and you'll go through all these statements. Now, the two styles that I said, you can either have a sensitivity list like this, that is process AB, or you write a wait on A and B at the end. You can have either this or this. You cannot have both. I hope that is clear. And again, only static names are allowed in the sensitivity list. So once the process is over, the process suspends at the bottom and the process will wait for this either A or B to change, then it will get called. Okay? So let's look at the different sequential statements that we can use as part of our process. The if statement is very clear. You have used the if statement in C, in C++. The concept is same, but the result or the hardware can be different. Please understand that, and you will understand that as part of the HDL course. But let's go through it first. If condition 1, then I will evaluate sequential condition 1. If condition 2, then sequential statement 2. If condition 3, sequential statement 3. If I have no condition and I have a default condition, then I will just say else and put in the last sequential. Please understand that this is else if. Else if is one word. It is as good as saying else and if. But this is not C in VHDL, this is how we write it, that is else if. Sequential statements like if statement will evaluate this condition first. If this is true, it will execute these statements and these statements are left out. On the other hand, if this statement is false, then it will evaluate this condition. If this is true, then it forgets this. So you can understand that it will evaluate each condition in order. And if statements can be nested. Now what do we mean by nested? For example, if I write if A is equal to B, then I can write another if X is equal to Y, then M is assigned N, which is the sequential statement. Now what I would do is, I would write else M is equal to X, okay, and if. So in effect, this if statement belongs under this if statement, and when I write the first end if, that is this one, I am actually ending this if statement. Please understand that. Now to continue the top level if statement, I would write else M is equal to Y, end if. Again, please don't spend a lot of time trying to understand this. This is just some basic assignments, but understand this. I can write the first if statement, inside which I can write another if statement, but the first end if will end this if statement. The second end if will end the main if statement. So basically you can nest the if statements. Basically if statements can contain other if statements. I hope this is clear. Let's take an example. This is your sensitivity list. If X is all zeros, then Z gets A. Else if X is 0, 1, 0, 1, then Z gets B. Else Z gets C. So as long as X is all zeros, this will execute and this will be not looked at. So if you see that I am using some sort of a priority structure like the when else in combinational, that always this guy has more priority than this guy and has more priority over this statement. It's a good design practice to avoid using more than 3 levels of if else. I will tell you why in the next slide, but try avoiding using more than 3 levels. And while defining the condition, you try and use brackets so that you know that if there is an if statement, if you nested another if statement, it avoids confusion. Okay? So let's look at what will be the hardware for the priority logic. Again, your sensitivity list will have A, B, C, D. if your select 2 is equal to 1, so let's say your select 2 is equal to 1, then your y will be a. So as long as this guy is 1, your y will always be a. At that time, I don't care about this, I don't care about this. Similarly, if this is 0, that is the other else if condition. So this else if condition will only be evaluated if this is not true. So if this is not true, that means select 2 is 0. If select 2 is 0 and select 1 is 1, then your y will be b. And similarly, now you can figure out for select 0. If this is 0 and this is 0 and this is 1, then this will be your path and not this. Now you see that again, this is a priority logic, that select 2 has higher priority than select 1 has higher priority than select 0. Now when I said that try use less than 3 if-else statements is because as you see that this keeps growing longer and longer, correct? Now the longer your path, the longer the, can you guess what? Delay or the time taken for the signal to get from here to here, because this is a 2-to-1 multiplexer and it has digital gates, it has and or gates. Now as we know that gates have delay and hence you have to take care of the time. So basically, avoid more than 3 levels to reduce delay. Okay? Again, it is very similar to the when else statement in the concurrent part, as you must have already realized. So let's look at the second part, that is the case statement. The case statement, or also known as case select, is very similar to the with select statement in your concurrent part. The basic syntax is as follows. Case expression is, so first the expression is evaluated, and if it is choice 1, then you will execute these statements. If it is choice 2, you will execute these statements. And then you need a default others clause like the with select, and then you will have a few statements, and then you would write end case. So basically your case statement is a series of parallel checks. So you will check parallelly, you check for a condition, and if this choice is accepted, then the statements inside are executed sequentially. So although you do a parallel check, but the execution of the statements is sequential inside. Okay, so the statements are evaluated only if the choice value, that is this choice, matches the expression value. It's quite straightforward. So let's look at an example. So the best example is a multiplexer. So again, it's a 4:1 multiplexer with 2 select lines. So case select is, again, the sensitivity list will contain all those signals. Again, the sensitivity list will contain all those signals whose changes will trigger my process. So case select is, when select is 0, y gets A. That is, when select is 0, 0, y gets A. When select is 1, that is 0, 1, y gets B. When select is 2, that is 1, 0, y gets C. Now, I can write this when 3, but obviously we know that if it's not 0, 1 and 2, then select would be 1, 1, that is 3, that is when others, y gets D. I would say end case and then end process. Now, if you see this very carefully, your with select statement is very similar to the case statement, and it does not result in a priority logic like the if statement. It does not.